In which pair of species do both species have only one unpaired p electron? Well, this question is from the electronic configuration, and we must have to find that there is one p unpaired electron. First of all, p subshell has three orbitals. They are px, py, and pz. So we will find and these choices with configuration to have one electron, that is an unpaired electron, or another configuration, any type of p configuration having one unpaired electron. So starting with choice A, argon. Now the question ke how I will remember the argon position in the periodic table or its proton number. You will be given a data booklet, but you must have to remember that which element belong to which block of periodic table. The block will help you to find the correct answer. Now argon belongs to P block and it is noble gas. Their electronic configuration is Ns2 and Np6. Means that argon has Np6 configuration. But there is a positive charge on argon, means that it loses an electron. So for argon positive, its P has now 5 electrons. And when we draw the orbital configuration, you will find that there are 3 electrons. This is the fourth one, the fifth one, and here is one unpaired p electron in argon positive. So this is our choice. But now looking to carbon negative, that is a carbonyl. Carbon, this belongs to P block and fourth group of periodic table. They have Ns2 and Np2 configuration. Now for carbon negative means that it has gained one electron, then we will get Ns2 Np3 configuration. Now for p orbitals, we will get that each orbital has one electron according to the Hund's rule. So there are 3 unpaired electron in the p subshell, so this is not matching to the choice. Coming towards choice B, that is boron and titanium. Boron belongs to third group of periodic table and their configuration is Ns2 Np1. Third group means that they have 3 valence electron. Now in boron we will get Np1. So the p orbitals, there is one unpaired electron in the p orbital. So this is according to the question. Now titanium. Titanium positive. First of all, titanium belongs to D block elements. So we do not need to configure it. If you want to configure it, then you will get titanium has atomic number of 22 and its configuration is Ns2 N minus 1 D1. So it has, means it has 4s2 and n minus 1 becomes 3. This n is the principal quantum number. So it is 3d1. When it loses its d electron or s electron, again its p orbital is here, which is 4p having 0 electrons. So it is not in our choice. Fluorine and gallium. Fluorine belongs to 7th group and 7 group elements have 7 electron in their valence shell, that is ns2 and np5. Here, if you look at fluorine, the p5 electrons are distributed in the orbital as 1, 2, 3, 4, and 5th. So there is one unpaired p electron. So fluorine is according to the question. Gallium. Gallium belongs to third A group. Again, boron family. So gallium has NP1 configuration. So NP1 configuration means that in the p orbitals there is one electron in the p subshell and that electron is unpaired. So it is according to our question. So the correct choice is choice C, in which both the species have only one unpaired p electron. Selenium and selenium negative and silicon negative. If you want to configure these, so let me solve these. Selenium is oxygen, sulfur, and selenium. This is sixth group of the periodic table, and they have electronic configuration ns2 and np4. Now for selenium, it has a negative charge, so means that selenium has np5. And when you draw the orbital configuration, there is 3 orbital, 1, 2, 3, 4, and 5th. So there is one unpaired p electron. So selenium is according to the question. Now coming towards the silicon negative, this is carbon, silicon, germanium, and tin. These are fourth group elements. They have 4 electron in valence shell, and their configuration is ns2 and np2. For silicon negative, then we will get the p has 3 electron, np3, and when we draw this, we will get 3 unpaired electron in the p orbital. So it is not according to the question. So the correct choice is choice C.